This is Lab 3, the Magnetic Field Lab. My name is David Luton. This is Physics 2212, Group X11, Fall 2020. The goals of this lab are twofold. First, we seek to experimentally determine an off-axis 45-degree magnetic field using constants derived from previous experimentation. Then, we want to computationally determine the 45-degree magnetic field at the same off-axis point to find an idealized version of that magnetic field. To do this lab, we'll be invoking some novel principles, including the magnetic field and the magnetic dipole moment. To minimize interference from outside magnetic fields, measurements were taken outdoors, sufficiently far from other sources of electromagnetism. With my latitude and longitude, Earth's magnetic field at my position was determined using the geomagnetic model at top left. Breaking this into components, I was able to align my phone with the magnetic north pole, which shifts from year to year in a process known as declination. The phone was also set atop a cardboard box, as this was found to help reduce fluctuations in the magnetometer app. The magnetometer chip of my phone was located, and on-axis fields were found in triplicates. Then, off-axis fields, 45 degrees from the bar magnet, were found in triplicates. It was assumed that after aligning my phone with the magnetic north pole, Earth's magnetic field was effectively corrected for. With my on-axis data, I was able to graph the natural logarithms of the distances, r, and the x components of the magnetic fields, bx, against one another, finding constants n, k, and importantly, mu, the magnetic dipole moment. N was found to be negative 3.051, k was found to be 3.470 times 10 to the minus 7, and mu was found to be 3.470. My off-axis magnetic field was found to be, on average, 5.260 times 10 to the minus 5 Tesla. With Glowscript Computation, the ideal 45-degree off-axis magnetic field could be determined using the distance d that was found experimentally. These results can be compared with my experimental off-axis results. The net magnetic field of the model was found to be 4.215 times 10 to the minus 5 Tesla, broken into components as shown just above. Now, in Glowscript there are no external magnetic fields to mess with my numbers. This can't be achieved in an experimental environment. Following both the hyperlink and the text link, you will find my Glowscript code. Without orienting my phone with magnetic north, a non-zero x component from Earth's magnetic field would superimpose on any magnetic field from the bar magnet, offsetting measurements by a constant factor. So, with this idea that magnetic fields are additive, by sticking two magnets together north to south, the magnetic field strength at any location in space would be approximately doubled. With this stronger magnetic field, the distance-dependent constants that were found, n, k, and the magnetic dipole moment mu, would also decrease. Ultimately, the requisite on-axis distances r for each x component of the magnetic field would also decrease, and finally, the 100 microtesla distance d for the 45-degree off-axis field would also decrease. This concludes my presentation on Lab 3, the Magnetic Field Lab. Thank you for watching.